Hello everyone, I am Jayashri. This is my first video on the YouTube. Today I am going to teach you a subject on artificial intelligence and soft computing. On artificial intelligence and soft computing, there are lots of chapters. One of the chapter I am going to teach you on the problem solving. In problem solving, there are some of the few important questions that university asks that questions repeatedly. So that questions must understand thoroughly and correctly so that you can write that answers in a correct way in the answer sheet that you can get the full mark on it. So let's start. Our first question is about the DFS. Okay, this is how the first question means. It asks the questions like write a short note on DFS, explain with example what's a DFS. So I will explain you first the theoretical part, then the practical, so that you can understand what's the DFS actually, and with example you can understand it correct and thoroughly, and you can write in your own words in the answer sheet. So let's start. Our first question is DFS. DFS is short form, it's long form, it stands for a depth first search. Okay, by reading this depth first search, I think you must understand something what's a depth first search. Means in DFS, it used to traverse all the nodes in the graph tree. Means it find all the unvisited node and make that all the unvisited node as a visited node with the help of the stack. Means with the help of the member of stack, they use to make all the unvisited node of the graph as a visited node. Its main goal is this, that make all the nodes as a visited. So how this they do? Means depth first search means it traverses a tree in a depth-wise manner. It traverses a tree in depth-wise manner means what? It starts from the root node, it ends at the leaf node. Okay. When it starts from root node, it ends at leaf node. It traverses from left to right. It neither starts from right to left or from center. It doesn't search. It only searches from left to right. So it starts from root node, it ends at the leaf node. After the leaf node means after the end of the leaf node, then there is no any other node. It do a backward motion. Why they do a backward motion? Note down that in DFS they use a recursive algorithm type, that is a backtracking. Backtracking is used because whenever there is no any further node to find and a same path to traverse a tree, it uses a backward motion. Because it uses a backward motion so that you can traverse all the node in the tree and you can find all the nodes and you can make all the node as a visited node. Okay, so this is the way the DFS do. So DFS is implemented by the stack member, that is an LIF list, means whichever elements that comes in the stack that first pop out, last in first out, that get first pop out from the stack. Okay, this is what the DFS do actually. So DFS has a two-step algorithm. One step that I will tell you that to make all the visited node as an unvisited node, from traversing from root to at the end of leaf node, and then do backward motion if necessary, but you must traverse the tree from left to right. Okay, this is the first step algorithm. Second step algorithm, it uses stack members, means whichever elements get visited, it put all the element, it push all the element in stack. After that, it makes the stack as an empty and to get the output. Now I am going to teach you practically one example so you can understand that what is DFS and what's the how it's working on everything. So let's start. Our first question is this is starting as root node. Okay, this is what's the root node. From this is the initial node which we have to start. We have to traverse the node and to find all the unvisited node as a visited node. So this will be root node, starting node. So this all will be connected all the nodes. So let's start. We will connect all the nodes. There are 5 nodes, edges are 6. These are unvisited node, and here are visited node. This all are just now unvisited node. You have to make all this unvisited node as a visited node with the help of the member stack. Okay, and here will be the output, that how we have searched the nodes and how that make our how we have completed the goal of DFS. Okay, so we will start. Our root node is S. So first we will take as root node as S, and then we will go to A. Okay, so first we will take S and then put on the stack. We will make this, we will put on the stack, and after that we will make this S as a visitor node. Okay, we will mark as a visitor node. After S we will go to the A. Why we are going to A? Why can't we go to B or C? Because I have already told you, after we must go to A, because start from left. Our A is standing on the left direction, so we have to go from left to right, neither from right to left or in center or in any way. We have to start from left to right to search a nodes in a tree. So to traverse, we start from A, then we put on the stack the element A. We will make A as a visitor node. After A we will go to D, because I have told that in DFS, in depth first search, it traverses till depth wise to the end of the leaf node. So we will take as a D. Okay. Then after D, there is no any further node. Then we will do a backward motion, because I have already told you that backtracking is important in DFS, because whenever there is any further node in DFS, then we have to find any rest of all the nodes which are there, which are unvisited. So for that, for traversing the nodes, we must do a backtracking. So that's why we have to do backtracking. We have to go to the node B. Then we will put on the stack element as a B, and we will make the B as a visitor node. Now everything in B, but for connection of B is connected with S, B is connected D, everything is visitor node. Now which nodes is remaining which is unvisited? That is C. C is remaining as an unvisited node. We can't directly jump into the C, because B is neither connected to C. B is only connected to S, B is connected to D, but C is connected to S and D. So we have to do backward motion, means we have to jump to the reverse. Okay, means then we have to go to D, otherwise to S. So I will take as a D first. I will jump to D, but our top element is a B on the stack. We have to pop out the element B, then only we can get the D element. So we have to first pop out the B, and we'll make as a D as the top element. Okay. After that, our D is the top element. We got as a D element. Our D is connected to C, which is the C is the unvisited node. Now we will put the C on the stack, and we will make as a C as a visitor node. Now you can see in our graph, there is every node is a visitor node. There is no any other node which is unvisited. So we have put all the unvisited node into stack, so we get the visitor node. So in this way here we have find the DFS, we have find all the nodes in tree, we have traversed the tree with the help of the DFS, with members implemented with the members with the help of stack. Now after the second step algorithm is that we have to pop out the element, we have to make a stack element as an empty, we have to make the stack empty. So our stack, how to make stack empty? Because I have already told you, the last in first out list get popped. Whichever elements comes in last, that first elements get popped out. So our first element is S, then after that A, then D, and then B, and then C. So this is the output we have got after popping from the stack. So this is what the stack, we have got the empty, and we have got the output, that how we have find the nodes and how we make all the visitor node as an unvisited node. So this was all about the DFS, which I have explained you the theoretical and the practical. Thank you very much.